Welcome, and thank you for standing by. All participants will be in a listen-only mode until the question and answer session. During that time, if you'd like to ask a question, please press star one. I'd like to inform all parties that today's call will be recorded. If you have any objections, you may disconnect at this time. I'd now like to turn the call over to your host, Ms. Karen Fox. You may begin whenever you're ready.
Thank you so much. Hello, everybody, and welcome. I am Karen Fox with NASA's Office of Communications, and I am excited to welcome you today to a media briefing on Mars sample return and its architecture. We have a few speakers lined up to talk at the beginning, and then we will move over to questions and take questions from the group on the line. The speakers we have today are Thomas Zurbuchen, the Associate Administrator for the Science Mission Directorate at NASA headquarters, David Parker, the Director of Human and Robotic Exploration at the European Space Agency, Jeff Gramling, Director of the Mars Sample Return Program at NASA, and Francois Spoto, Head of Mars Exploration Group at the European Space Agency. We will start with our presentations, and then they'll hand it back to me, and we'll start the questions. And with that, I will hand it over to Thomas Zurbuchen.
Hey, thank you so much, Karen. And I want to tell you, I'm in Europe right now, and I've given quite a number of presentations, both in the U.S. and in Europe, and recently much about the James Webb Space Telescope. And I just, as I'm sitting here thinking about Mars sample return, I recognize the enormous analogies of this. Both are historic missions, both are international. They're big missions that are both difficult, but are very much worth doing. And in the case of what's happening with Mars sample return, the mission is happening right now as we speak, because while the Perseverance rover continues collecting scientifically selected samples on Mars right now, we're pleased to be here today with our European Space Agency partners to provide an update for bringing those samples back to Earth. The Mars sample return program is nearing completion of its conceptual design phase. During this phase, known as Phase A, the program has been working diligently to study concepts for returning the high-value samples with the greatest degree of success. Considering this phase, during this phase, the program examined a number of configurations to collect the cached samples from the surface of Mars and deliver them to the lander carried by the Mars Ascent vehicle that will bring it back home to Earth on the Earth Return Orbiter. Earlier this year, during Phase A, we announced an iteration that added a second lander to carry the sample fetch rover to Mars due to the mass requirements of the missions. We're learning a lot as we go forward, not only about the analysis of this, but also about Perseverance that's right now on Mars. So now with the conceptual design phase nearing completion and following the mission definition review, we have a path forward using a revised and innovative architecture. We reached our decision based on new studies and recent achievements at Mars that allowed us to consider options that frankly weren't available to us 1 year ago or before. This new architecture relies on the Perseverance rover as the primary delivery system to bring samples to the sample retrieval lander, where ESA's sample transfer arm will load the sample tubes into the Mars Ascent vehicle built by the United States. And we're adding 2 Ingenuity-class helicopters as backups to transport the samples to the lander. The successful operational demonstration of the Ingenuity helicopters on Mars, frankly, was key to allowing us to consider and adapt to this change. So I'm going to hand it over to my colleague and friend, David Parker, the Director of Human and Robotic Exploration at ESA. You've introduced Karen, our partner in this effort, to discuss ESA's very important contribution to the Mars Sample Return Program, including the sample transfer arm and the Earth Return Orbiter. David.
Thank you very much, Thomas, and good day to everyone from my side. Yes, thank you very much. It's great to have the opportunity to participate in this update on the Mars Sample Return Program. It is for ESA a very exciting program and a very important partnership with our friends at NASA. I always say that Mars Sample Return is a unique mission because it combines both scientific and exploration goals by returning what I say are priceless scientific treasure from the red planet that will be studied in laboratories here on Earth worldwide for the next 50 years. It will answer fundamental questions about Mars, its early history, and its relationship with the Earth and indeed the whole of the solar system. A very, very simple example, but an important one. It will allow for the very first time absolute age dating of rock and soil taken from a known geological context on the red planet, and therefore provide ground truth to calibrate the age of all of the features of Mars for the first time. So at the same time, Mars Sample Return is you can think of it as an essential precursor or a stepping stone to an eventual human mission to Mars by demonstrating the engineering and operations of a complex multi-element mission up to 400 million kilometers from Earth. So I give you just one engineering and one scientific example to emphasize this point. ESA's Earth Return Orbiter that we're building right now, it's well into its Phase B and past the preliminary design review. The Earth Return Orbiter ERO is a multi-stage spacecraft equipped with both chemical and solar electric propulsion, more powerful than has ever been used on any previous planetary mission. So it's a technological challenge. But aboard the Earth Return Orbiter will be a radiation sensor being developed by one of our participating states in ESA, the European Space Agency. That's Hungary. And they will be this instrument will measure the total radiation dose experienced over the whole mission. So traveling to Mars, operating Mars, and returning home to Earth. And this will therefore provide important information to assess the risk to future human explorers. So having set the context of the Mars Sample Return program, I'd like to hand over to my colleague Jeff Gramling from NASA, who is the Mars Sample Return program manager there. Jeff, please.
All right, thank you, David, and good morning and good afternoon to everyone. We've reached a significant milestone in this campaign to return samples from Mars. Of course, the architecture for that campaign, beginning with Perseverance, is really designed to go where the scientists want to go to collect the samples to answer the questions that are being asked. Of course, we've already collected, Perseverance has already collected 9 scientifically selected samples that are there and ready to be brought home. On July 15th, completed the mission design or the mission definition review looking at the overall program, including the architecture, the requirements, mission or the organization, risk, and schedule. As Thomas described, key to our new architecture is a recent assessment of Perseverance's reliability and life expectancy based on its performance to date. And that assessment also took into account the performance of Curiosity. It's nearing its 10th year of operation on Mars. There's much shared heritage in the mobility system. Based on that updated assessment, we have confidence that the rover will be available to deliver samples to the sample retrieval lander in 2030 when we need it to be. So it's the primary path. Recent operations of the Ingenuity helicopter on Mars, which have completed 29 flights, 24 more than originally planned, have shown us the usefulness and potential of rotorcraft on Mars. In recent months, studies conducted at JPL have evaluated the possibility of adding Ingenuity-class helicopters to retrieve samples and to deliver them to our lander. With those studies, we are confident in adding helicopters to perform the role of backup to Perseverance and transporting the sample tubes to the sample retrieval lander. The 2 Ingenuity-class helicopters will be carried to Mars on the deck of our lander. The single lander will also carry the Mars ascent vehicle and the ESA-provided sample transfer arm. The plan for Perseverance is to drive to the landing location of the sample retrieval lander. There, ESA's sample transfer arm will extract the samples from Perseverance and load those samples into the Mars ascent vehicle. While we're adding helicopters as backups, many components of the program have not changed from the original architecture. We have a single sample retrieval lander now augmented with the Ingenuity-class helicopters, the Mars ascent vehicle, the sample transfer arm, and ESA's Earth Return Orbiter, with the NASA-provided capture, containment, and return system. All of those remain unchanged. It's still early in this program. Our next key decision point is in September, at which time we expect to finalize the new architecture and move into our preliminary design phase, which is phase B. Next, we will hear from my colleague, Francois Spoto, the head of the Mars Exploration Group at ESA. Francois?
Thank you very much, Jeff, and good morning, good afternoon to everyone around the loop. A lot has been said already, so I will focus a bit more on the ESA deliverables, which are Earth Return Orbiter and Sample Transfer Arm, and make also some comments on Sample Fetch Rover, which was also one of our development until now. So Earth Return Orbiter, the mission is between preliminary design and critical design review. Critical design review will happen in September next year. The launch is due in 2027 in order to secure the return of the samples on Earth in 2033. That's pretty important. And Aero is carrying one major payload delivered by our friends at NASA, the Capture, Containment, and Return System payload, the CCRS. And together with this payload, Aero will be able to rendezvous the orbiting sample in orbit around Mars, approach this orbiting sample carefully and capture it before bringing it back to Earth, where basically in the desert of Utah, samples will be recovered and transferred into a safe and controlled place for later utilization and scientific exploitation. STA, Sample Transfer Arm, is a robotic arm pretty comparable to a human arm actually. It is equipped with a gripper at the end, which is able to catch samples from Perseverance. Initially, it was also designed, of course, to catch samples from Sample Fetch Rover, and it is now being adapted to catch samples from the gripping helicopters as well. The contract was signed in July, so very, very recently, at the opportunity of the Farnborough Air Show in the UK, with a company in Italy called Leonardo. It's an international group that has also a branch in space robotics. Now, Sample Fetch Rover is until now one of our development, and we have reached PDR. But we've been working very hard with NASA over the last 16 months, I would say, to try to consider, to reevaluate what will make the mission ultra-reliable in order we build the maximum level of confidence into a safe return of the sample we want to return for scientific exploitation. And finally decided that the best for the mission was to discontinue Sample Fetch Rover, why also because at that time we had a very clear understanding of the extreme reliability of the Perseverance rover, which is or was in itself designed and conceived to bring the samples to the bottom of the landing platform, where STA would be able to fetch from Perseverance the samples and hand them over to the Mars ascent vehicle that was mentioned before by Thomas. So by doing that, we limit, of course, risk to the overall mission. And we also avoid significant extra cost because we can return to the very initial concept where we had only one single lander within the system. Now, by the way, this is the configuration we've been reviewing 2 weeks ago at the level of the mission definition review together with NASA, where the program was exposed to a board of experts who had basically to consider the work done until now. And the capability of the teams to switch from a phase A to a phase B. And the review was quite successful, even though we collected a number of very good hints on how to make the mission more secure and more reliable. Now, I would like to say that until now, let's say this cooperation has really started in 2020. This is the time when we signed the memorandum of understanding. So we have already quite a significant experience to deal with each other, especially with my colleague Jeff, who is in the group as well. And the relationship between both organizations is very good, and also together with the Jet Propulsion Lab, with in charge of the campaign realization under NASA. Now, after James Webb Space Telescope, I think MSR is once again an excellent case of cooperation between NASA and ESA, and we are all really motivated at ESA to really push this program forward and to make it a good success together. Thank you. This is what I wanted to mention as an introduction.
Thank you, everybody. Thank you so much. We will move on to the questions portion. However, I do think we have an update about the samples, so I was going to toss to Thomas to give us an update about where Perseverance is in its sample count.
Do you mind, Karen, if I just kick this to my colleague who's also here, who is not a speaker right now, but is, of course, thinking about these samples more than anybody else, and that's, of course, Minnie Wadwa, who's the MSR principal scientist. Minnie, do you want to do the update quickly and tell us what happened last night? Go ahead.
Yeah, thank you so much, Thomas. So we've actually got an incredible sample suite already that we've collected to address some of the highest priority science questions, as David Parker said, priceless scientific treasure. So we actually have 10 samples, rock samples that have already been sealed and stored, and an 11th sample that we are in the process of doing so. These represent an amazing suite of materials. The latest one, in fact, is a fine-grained sedimentary rock that we hopefully, will contain some of the, has the greatest potential for preserving biosignatures potentially. And so we have, again, a diversity of materials already in the bag, so to speak, and, really excited about the potential for bringing these back.
Great. Thank you so much. And now we really will go to the Q&A portion. So I'm going to toss it quickly to our operator, Becca, to remind everybody how to get on the queue, and then we will start taking your questions.
As a reminder, if you'd like to ask a question, please press star one. Again, that is star one. 1 minute, please, for our first question. Our first question comes from Elizabeth Howe of space.com. Your line is now open.
Good morning. Not sure who can answer this, but I wanted to find out how those Ingenuity-type helicopters would work, how mechanically they would pick up the samples and do the retrieval. Thanks so much.
Hi, this is Jeff. My colleague Richard Cook, who is the program manager for Mars Sample Return at JPL, is here with me, and I think he can answer this question.
Sure. So this is Richard. The basic approach is to build a helicopter, or two helicopters actually, that look a lot of ways like Ingenuity in terms of size and overall mass, a little bit heavier, but basically the same size, with a couple of notable differences. One is that there will be, rather than landing legs, there will be landing legs that include at the bottom of them mobility wheels, basically, some very small wheels that allow the helicopter to traverse across the surface on the ground, as well as fly. And secondly, each of the helicopters will have a little arm, basically, that can reach down and grab onto one of the tubes that the sample tubes that Perseverance will have placed on the surface of Mars. And so in the scenario that we're talking about, where the helicopters are used, each of the helicopters would be able to operate independently. They would fly out to the depot location from where SRL lands, would land in the proximity of the sample tubes, roll over to it, pick one up, then fly back to the proximity of the lander, roll up to the lander, and drop it in a spot on the ground where the ESA sample transfer arm could pick it up and put it into the map. And so each helicopter would be doing that separately, and over the course of 3 or 4 days, or 4 or 5 days per tube, would go basically sortie out and get a tube, bring it back, sortie out and get another tube back, and bring all the sample tubes back to the proximity of the lander that way.
If I may ask a quick follow-up, what's the primary mission of the two helicopters?
So the situation that we're talking about is that they would be used as a backup to bring the tubes back to the lander. There's also the possibility that we can do other things with it, in terms of observing the area around the lander, potentially taking pictures of the MAV launch when the MAV does take off, things like that we're still talking about.
Great. Thank you so much. We are ready for our next question.
Our next question comes from Marcia Dunn with the Associated Press. Your line is now open.
Yes, thank you. I may have missed it in the course of conversation, but when is the targeted launch of the Mars ascent vehicle with the helicopters, and what is the targeted date for getting these samples back on Earth. And was the switch to using Perseverance as the main pickup vehicle and the two helos as a backup, was this driven by price savings and or saving time or some reason? Thank you.
So this is Richard Cook. I'll answer the first question, and I think Jeff will answer the second. The planned arrival of SRL on the surface of Mars will be in mid-2030, 2030, and the MAV will launch about a little less than a year later, so early in 2031, leading to a return of samples to the Earth in 2033.
What was your second question, please?
I'm just wondering what led the drive to using Perseverance as the main pickup vehicle with two helicopters as backup. Was that to save money? Was that to save time? What drove that decision to use what you've got instead of having something new coming from Earth? Thanks.
So the plan has always been to use Perseverance, and we had the sample fetch rover as well. We had two ways to bring samples back in the architectural revision that we have. We based on the results of our reliability assessment, we're going to plan on using Perseverance as the primary because of what we've seen on the performance we've seen on Mars today, both of Perseverance and Curiosity. So we have confidence that we can count on Perseverance to bring the samples back, and we've added the helicopters as a backup means to assure that in the event of a Perseverance failure, that we can that we still can bring samples back. This mission is simpler, it's less organizationally complex, and we believe now that we have an architecture that, again, is simpler and is going to position us for success based on the analysis we've done.
Thank you so much. Moving on to the next question.
Our next question comes from Bill Harwood with the CBS News. Your line is now open.
Hey, thank you very much. I'm not sure who this is for either, but three quick ones about the helicopters. I don't recall the weight of the sample tube. I know it's in a press kit, but I was wondering the max weight that these two retrieval copters can carry. Wondering how far can they sortie to go pick up a sample? What's the max distance from the lander that you would want to send them out and bring them back? And you keep calling this a backup. I guess what I'm wondering is if Perseverance stays healthy, is there some chance you wouldn't use the helicopters at all? Or would you plan to pick up at least some samples with the helicopters just to demonstrate the technology? Thanks.
So this is Richard again. I can answer the questions. The filled sample tubes are about less than 150 grams. So that's it depends on how much, of course, sample is in them. But with a fully filled up tube, it could be as much as 150 grams. I think you asked about the sortie distance. So the maximum distance that we think the helicopters would need to sortie out and back out is like 700 meters. And we've demonstrated flights about that long on Ingenuity, so we know it can make it that far. But the reason why it wouldn't be longer than that is because we're landing SRL very, very close to where the depot of tubes would be. That SRL is being designed to land within about 50 meters of a spot on Mars. It's got a pinpoint landing capability, and that will allow us to get very, very close. The question you asked about the scenarios for which the helicopter are used, it very much depends on how Perseverance health looks over the next 8 years, and so that it could range between only needing to be there to support the final approach of Perseverance, as well as some of the other things I talked about, or it could be needed to move all of the tubes, again, depending on what happens with Perseverance's operations over the next 8 years.
All right, thank you. We'll move on to the next question.
As a reminder, if you would like to ask a question, please press star one. Our next question comes from Kenneth Chang with New York Times. Your line is now open.
Hi, thank you. So I guess this would be for Richard or actually for Perseverance people. How is this going to affect Perseverance mission, and where would the notional landing spot be would it be outside the crater because that's where Percy would be heading to, or would you double back?
So yeah, Minnie might want to jump in on this too, right? But the basic plan for Perseverance is to continue to do the Jezero Delta campaign that they're in right now and acquire a set of samples, over the next few months, which will likely be put into a first depot on the surface sometime later this year as a sort of insurance policy, you might say. And then after that, drive up through the rest of the Delta, Jezero Delta, and then eventually leave the crater and go on to the Midway site, which is some of the more ancient terrain on Mars. And in that case, it would continue to acquire samples through that whole time frame. And so, in fact, we could land SRL out, wherever Perseverance ends up. And the intent is that it not come back to Jezero in that case. I don't know, Minnie, you want to add anything else?
No, I think main idea is that we haven't actually changed anything about planning for where the samples depoted. So you're right. The first depot is most likely going to be in a few months' time within Jezero Crater as an insurance policy, and then we'll of course carry the rest of the samples. And of course, Perseverance has been collecting duplicate samples, which means that there'll be a set of rock cores on board that will be duplicates of the ones that are going to be deposited within Jezero, and we'll carry those out with it towards Midway and continue collecting.
Thank you so much. That was Minnie Wadhwa, the Mars Sample Return Principal Scientist, and again, Richard Cook, who is the Mars Sample Return Program Manager, who has been invited to answer some of the more detailed questions here today. With that, we will move on to our next question.
Okay, our next question comes from Marina Corinne with The Atlantic. Your line is now open.
Hi, Marina Corinne with The Atlantic. Two questions. So it sounds like Perseverance has got a promotion here. Will the team need to make the rover do any operations and maneuvers that the machine wasn't expected to do? And then second question, Martian helicopters are still, I'd say, a pretty experimental technology. So what would you do in a scenario in which both Perseverance and the new helicopters then fail? Thank you.
Let's start off with Jeff Gramling, and then we may go further with Richard.
So we have the two paths to bring the samples back to our lander for, that we would ultimately use the map to launch them into orbit. Those are Perseverance remaining healthy and the helicopters. What was the first part of the question?
The first part was just about the are we changing the way we're going to operate Perseverance? The answer to that is no. That the intent, as Minnie said all along, was for Perseverance to get a great set of scientifically selected samples and be in a position to provide them to MSR to bring back to the Earth. And so at this point, we expect to continue to operate Perseverance within its tested, operating envelope. So we're not going to try to do new things with it. We're going to continue to perform as we've designed it to do what we want. And I think our overall approach in adding the helicopters, as Jeff said, was to provide a backup capability to what is the prime path of Perseverance, which we have a lot of confidence in, given that it's been operating successfully. And I don't know that he mentioned it, but it's also very much, I think you all know, Perseverance is very, very much of a twin to Curiosity. And the Curiosity rover is coming up on its 10th anniversary on the surface of Mars, I think, next week. And so it has been a good demonstration that a rover of that caliber and that class can survive on the surface of Mars for 10 years.
And then, as I'd mentioned earlier, the plan had always been to have Perseverance bring samples back. So we had two paths. So that part of the plan is not changed.
All right. Thank you so much. On to the next question, please.
Our next question comes from Jeff Foss with Space News. Your line is open.
Good morning, good afternoon. How does this revised architecture affect the projected cost of the overall Mars sample return campaign? How much money are you going to save with one fewer lander and without a fetch rover? Thanks.
Hi, this is Jeff. So obviously, one lander is much less expensive than two. We're still in our preliminary design phase. It's what we call our key decision point C, which will be about a year from now that agency commits to cost. So during that period, we're doing cost estimation, and that's when we commit to a number. So all I can say right now is the obvious is one lander certainly is much less costly than two.
All right, moving on to the next question.
As a reminder, if you'd like to ask a question, please press star 1. Our next question comes from Irene Klotz with Aviation Week. The line is now open.
Thanks very much. I'm a little confused about what Perseverance role in the sample return campaign. Do the samples that are stored on board, which previously were considered backup, become the primary sample set that's returned to Earth, or does Perseverance go back to where it's going to be caching samples on the ground and pick those up for return? And then also maybe Jeff or Thomas or Richard, can you just maybe tell us a little bit about the novelty of adding the helicopters to the architecture? Like, how did that come about? Was there reluctance? Was everybody really eager to test it out? Or when did that very unique idea kind of move into what would be the main planning for the campaign? Thanks.
Perhaps I start in this case first, if that's okay. The first thing I want to say, it's Thomas, of course, the head of science at NASA. The first thing is, from the beginning, we always had two options to get the samples back. And I just think that's prudent to do, especially, remember when we started planning this, we actually hadn't even landed Perseverance on Mars. We didn't know, and frankly, there were a number of specific systems, especially mechanical systems, that relate to the sample acquisition and so forth, that really wanted to get some experience with. So our risk analysis, so to say, on Perseverance has really been affected by the experience that we've had in the last year. So that is number one. So it's not that Perseverance was not important and now it's important. We always wanted to have two, and of course, the sample fetch rover was one of the options to do that. The other one with Perseverance, and we wanted to be sure that both options were there. So in that sense, that was not substantial kind of zeroth order change. It was just an evolution of that as we learned about both Curiosity but also Perseverance. God, I just forgot the second question. Can you remind me?
Yes, I was asking about what happens with the role of Perseverance in the sample return if the cache samples aboard previously considered the backup become the prime to get back, or if there's some other role, and then just a little bit about the story of how the helicopter became part of this operational mission. Who thought of that, and how did that idea mature?
So again, I think I tried to address the first question as much as I can, and if others want to add, they should do that. On the helicopters, I just want to say ingenuity was really important for that, right? Because again, when we started planning, helicopters, on Mars were a dream and an aspiration of a technology demonstration. And frankly, there's with the flights that are up there, 2,000 and counting and more, right? We have gotten experience, and then frankly, helicopters as a tool here have really moved in the realm of the possible. But that's, by the way, why we do technology demonstration, is to take things that were too risky or kind of crazy to think about at the beginning and put them in the realm of the possible. It's just in this case, the timing worked so fortunately that in this conceptual design phase where multiple options are considered, the helicopter option in fact became reality kind of that the entire team basically felt comfortable with. Richard, do you want to take it away kind of again on the first question I was asked, or Jeff?
Yeah, I'll just, sort of repeat and reiterate what you said, right? That the plan all along has been that Perseverance would, after landing, would acquire a set of samples, and many mentioned as two at a time, right? Two for each rock, with the idea that after it had collected, on the order of 10 samples, that it would place, which drives along carrying those samples, it would place the first set of 10-ish in the Jezero area as a so-called first or contingency depot, as a sort of insurance policy. And then it would continue going, carrying the second copy and continuing to acquire new samples to the, eventual point where it has used all the tubes. There's a total of 43 tubes on Perseverance. And at that point, it would have on approximately 31 sort of tubes. That's what the scientists all along have wanted. That's what they want, right? The contingency is exactly that, a contingency. But the idea all along was those 30 samples that Perseverance ends up acquiring, over the next 6-7 years are the ones that we want to bring back. And so those are the ones that either we would get directly from Perseverance, either we will get directly from Perseverance, or if Perseverance happens to, if we don't believe it's gonna last that long, then we can put them into a second depot on the surface, at which point then the SRL will land close to it, and it will use the 2 helicopters to go get those 30 tubes and bring them back to the MAV. Does that make sense?
Yes. So under the optimal plan, the depot at Jezero Crater, those canisters just remain on Mars.
That's right, and there's certainly, hopefully, future opportunities to go get them, but we will have duplicate copies of all of those samples that will come back. So we're not, in a sense, missing anything by leaving those there.
Well, there's an X prize for you. Thank you.
Thanks so much, Irene. We'll move on to our next question.
Our next question comes from Alexandra Whitsey with Nature Magazine. Your line is now open.
Yeah. Hi, thanks for this. My question is for David Parker. So with the removal of the Fetch rover, when is ESA going to next land a rover on Mars?
Thank you very much, David Parker speaking. It's a great question. I'm afraid I can't answer that with any, definitively now. You're obviously referring to what happens to the Rosalind Franklin rover, which right now is sitting in the clean room in Pennsylvania Space in Turin, waiting for its trip to Mars. I can say that since the decision to discontinue or suspend the cooperation with Roscosmos in the spring, the engineering team has been working at great speed to find an alternative approach for delivering the Rosalind Franklin rover to Mars, and we've reported on that most recently to our governing council just a few weeks ago. And I would like to say that because it's been said already by the Director General of ESA and indeed the Administrator of NASA, that there's been some excellent discussions between NASA and ESA to explore the different options for getting Rosalind Franklin to Mars. And we still think that is something that we should try to do. But eventually it will be a decision for our member states to decide at our upcoming ESA Ministerial Council meeting in Paris towards the end of this year, in November this year.
Thanks.
Thank you. We will move on to our next question.
Our next question comes from Marcia Smith. Your line is now open.
Thanks so much. My question is along those same lines for the ESA representatives. So are you relieved that you don't have to build the sample fetch rover because now you can invest more in getting the ExoMars rover there? Or are you disappointed? How are you feeling about all this change?
Well, maybe I should have a go at that question, and maybe Francois may want to follow up. The engineer in me was fascinated by the sample fetch rover because it was designed to travel much faster than previous Mars rovers, probably about 4 or 5 times as quickly over the surface. But equally, from a program management point of view, as soon as it became clear that the sample fetch rover could not be accommodated alongside the Mars Ascent vehicle, and therefore it would imply a second launch, a second lander, and so forth. That implies cost and risk, and programs don't like cost and risk. So finding a way to balance out the cost and risk by undertaking the mission without the sample fetch rover makes a great deal of programmatic sense. So I think that summarizes our perspective. But Francois, you may have some thoughts as well.
Thank you, David. Maybe one angle to answer the question is also to say, okay, we had reached preliminary design review with this sample fetch rover development with Airbus in the UK. So indeed, we have a number of technologies that were developed, risks that were mitigated. We have even headboards related to locomotion or related to sample fetching, meaning robotics again, that were achieved by the Airbus UK industry. But everything is not lost because those developments could be very much valid if we would reroute them in the future to another kind of mission, like conceiving a rover mission to the moon. As you are aware, ESA will propose as part of the exploration program at the ministerial end of November, the ministerial that David mentioned before, a large lunar lander, which would have the aim to carry to the moon either cargo or payloads or payloads that could be as well roving vehicles. So we are going to study now together with Airbus UK how basically to redirect the know-how that was developed in the past, in the last 2.5 years, in order to see how we could reuse those activities and the outcome of those risk mitigation and breakboards in order to prepare potentially for a new development that will be targeted to another planet.
Thank you so much. We will move on to the next question.
Mm-hmm.
Our next question comes from Leo Enright with Irish Television. Your line is now open.
Thanks very much. I think this is probably for David Parker. Just trying to understand the role of the sample transfer arm. I mean, there was to be an arm on the Fetch rover. This is obviously not the same arm. Can you just describe how this arm what role it will play? And is this a new addition, or was this always part of the MAV design? I wasn't entirely clear. And if I could maybe just sort of be more precise, my understanding is that in a perfect situation, the Perseverance rover will back up to the MAV, and the European STA will reach out and take each sample. Am I broadly correct in everything I say there? I hope I am.
Okay, thanks. Hi, Leo. Yes, absolutely. The last point is a correct understanding. And indeed, the sample transfer arm has always been part of the foreseen architecture. So it's been studied by 2 different industrial contractors, and then we've moved forward with the preferred contractor signing the full development contract last week in Farnborough. Separately, the sample fetch rover would have had an arm to pick up sample tubes. But again, so that's no longer required. So yes, the sample transfer arm, fully extended, it's something like 2.5 meters of reach. It's a multi-jointed, very sophisticated robotic arm with end effector designed to pick up the sample tubes from the carousel on Perseverance on one side. And now, as you've understood, the possibility to pick up sample tubes deposited on the surface by one or other of these 2 Gripper helicopters. Is that clear now?
Yep, thank you very much.
All right, thank you, Leo. We will move on to the next question.
Our next question comes from George Dvorsky with Gizmodo. Your line is now open.
Hi, thanks everyone for doing this today. I'm wondering, does the proposed change to the architecture now have any effect on the safety, and in particular in regards to the issues of contamination? Did it alter anything, both in terms of what the helicopters might do, the return of the samples? I'm just wondering if that was any part of did that enter in any part of the conversation as you guys were thinking about these changes? Thanks very much.
This is Jeff. No, first order, our planetary protection regime remains unchanged, and this doesn't introduce any safety issues that we are having that are driving just other design changes. Richard can.
That's exactly right. The encapsulation approach that CCRS follows and the Earth return are all the same, unchanged.
Thank you. Thank you so much. We will go on to the next question.
As a reminder, if you'd like to ask a question, please again press star 1. Our next question comes from Nadia Drake with National Geographic. Your line is now open.
Hi, thank you for taking my question. This one I think is also for David Parker, and it's following up on Alex's question about ExoMars and the Rosalind Franklin rover. And I'm wondering if you'd be willing to share some of the options that you've been exploring for getting the Rosalind Franklin rover to the surface. What sorts of partner agencies might be in the picture, and what kind of timeline seems realistic at this point? Is 2028 still possible? Thank you.
Thank you very much for the question. Yes, in short form, a number of different options and launch dates are being explored. Launches to Mars are possible roughly every 2 years or 26 months. But within that, there are several sub-options for launch dates, and all of those are being considered, but 2028 is one of the possibilities. And so those trade-offs and considerations are continuing right now and will carry on up until the member states are ready to make a decision on whether or not to continue with the mission.
Thank you so much. We'll move on to the next question.
Okay, our next question comes from David Curley with the Discover Channel. Your line is now open.
Thank you very much. Thomas, not to belabor this point or anybody else, it always seemed as if with the Fetch rover and the dropping and caching of samples that was going to be the primary return. I understand redundancy in having two systems. Were they equal, and is now Perseverance really the main retrieval system? Thank you.
You're asking me, right? It's Thomas here.
Yeah, you tried to explain it, so I mentioned I just didn't want to push any further. I'm just trying to get a sense, were they equal before and now Perseverance is more, the main plan for retrieval?
Yes, they had to be equal before, because frankly, if you look at the overall risk of getting those samples back, kind of entirely relying on Perseverance was frankly far from realistic or reasonable. And, also, if you bring another rover there with its own lander, the likelihood of that certainly, as we know, landing on Mars is hard, is not 100% either. So kind of if you looked at the mission overall from the beginning, the way we made had our discussion with Europe, it was kind of to have the two channels to really bring the samples back and have both of them available for the success of the mission. It is true that at this moment in time, based on the knowledge we have, both, again, an in-depth analysis from Curiosity and also what we've learned from Perseverance, we're a lot more comfortable to make Perseverance the primary the primary option of getting the samples there. And so for us, that is because of things we learned on Mars, and it's also because of things we have analyzed that, frankly, we couldn't do before. So in that sense, it really has shifted in terms of its emphasis. Jeff, anything you wanted to add?
No, Thomas, I think you got it all right. We were planning on both options before. Based on, as Thomas mentioned, the health of Perseverance, its performance to date, coupled with Curiosity performance with 10 years of history with the mobility system, we have confidence in relying on Perseverance, and we're adding the helicopters to make sure we've got a viable backup mechanism in the architecture.
Thank you. We'll move on to the next question, please.
Our next question comes from Leonard David from Inside Outer Space. Your line is now open.
Thank you. Because of the revised architecture, is there kind of a need to do another independent review of cost and risk, something like the David Thompson study that was done? The second part, I'd like to get back to David Parker. Is the potential of using ExoMars for Mars sample return off the table?
I'm going to answer the first one. I just want to say how valuable the independent review that David Thompson and his team did was for the entire international team here. And frankly, many of the recommendations that they made, many of the issues that they surfaced were very much, verified by the team as they went through it and have been found valuable. We have, of course, a standing review board that is chaired by Maria Zuber. Dr. Maria Zuber, a very experienced scientist and leader. And we have that independent review, independent assessment at all times. It is also true that as I'm looking at the team going forward, any and all options of helping the team remain on the table, but at this moment in time, I don't believe that the pivot here certainly necessitates a totally independent look, because I think the transition has been very organic and with the right type of oversight from independent viewpoints such as standing review board. David, I'll give it to you for your question.
Yeah, thank you very much, Thomas. It's a really interesting question. If I understand it, could somehow Rosalind Franklin rover be adapted to support the sample fetch, the Mars sample return campaign? It's an interesting thought experiment, but when you start to think about it, the answer is fairly quickly no, because Rosalind Franklin is built as a kind of mobile science laboratory, but with its key feature being exploration in 3 dimensions, i.e. the drill going 2 meters below the surface in order to acquire samples that are not damaged by radiation, and therefore put those samples into an astrobiology laboratory. And all of that has been built and integrated and tested in quite extraordinary cleanliness environment. Whereas on the other hand, the purpose of the sample fetch rover is not to carry out science itself, but travel rapidly, quickly, go and fetch samples and come back again. And it would be a little bit completely repurposing and redesigning and rebuilding. So it doesn't make sense in the context of the Mars sample return campaign.
Thanks very much.
Thank you so much. We do still have quite a few questions. I'm hoping we can get to 3 more, and we are prioritizing those who haven't had a chance to ask a question yet. But please go on to the next question. Anyone who doesn't get a chance to ask a question here, we will, of course, try to answer your questions offline. But for now, let's go to the next question.
Okay, our next question comes from Paul Marks with Aerospace America. Your line is now open.
Hi. China has said it will bring home samples 2 years ahead of NASA and ESA from Mars. It strikes me that removing a whole rover is quite a feat in streamlining the mission, as you've done, getting rid of the fetch rover. So is it possible that as the decade moves on, you might be able to streamline it further and match or beat the Chinese in getting the samples back?
So I think the first thing I want to say is that, of course, I'm sure I speak for the international team here, is that we welcome any and all investments worldwide on the peaceful exploration of outer space, and especially as these explorations are done with the principles of openness and so forth. And so I have to tell you that I don't know much in detail about any other design, kind of outside of the one that we're working on. Probably read the same story you did, but I really don't know much. As to the flexibility in the future, I think I'm going to kick it to Jeff or Richard just to kind of talk about that.
So what I will say is our architecture, beginning with Perseverance, is underway. We've collected samples, and what we're doing is we've built an architecture, and the complexity is driven by the desire to accommodate the need to go where the science takes us, and that's what Perseverance has successfully been doing thus far, is going to the places where the science team believes there are worthy samples to bring back, and it's that complexity that kind of drives our mission architecture, and I'll leave it at that.
All right, thank you. Moving on to our next question.
Our next question comes from Antoine Monier. Your line is now open.
Yes, hello. Just one quick precision, please. With now the two helicopters, do you plan to bring back the same weight of samples than it was with the fetch rover?
This is Jeff. I'll let Richard answer that question.
Yes, the plan is to still have the capability to bring back the full number of 30 samples. The orbiting sample canister that we're taking with us to bring the samples back has space in it for 30 samples, and that's what we're going to bring back with the fetch rover, and what we will bring back whether Perseverance delivers it or the helicopters retrieve them.
Thank you.
Thank you. We have time for just one more question, and then we will close up today. But our last question for the day, please.
Our last question comes from Daniel Cleary with Science Magazine. Your line is now open.
Hi, thanks everyone. I just had another question about the number of sample containers. You say that Perseverance is currently making duplicate samples, so it keeps one within itself and puts another in depots on the ground. If it continues to do that, doubling everything, it won't end up with 30, carrying around 30 samples, because there's a total of 43, you said. These numbers don't seem to add up. How are we going to have 30 samples inside Perseverance?
Could I take that? This is Minnie Wadhwa, MSL Principal Scientist. So the plan is to collect the duplicate samples only within the Jezero Crater campaign during that phase of the mission. And so up to this point, we have, the 43 tubes that are on there. We've got one tube that's filled with atmosphere. We've got a couple of tubes that are witness tubes, which is essentially blank, help us with sort of assessing blank values. And then we've got, at the current time, 10 that have already been, actually, the 11th sample was just successfully sealed and stowed just now, actually. So we've got 11, and we're going to be, and all of those rock samples that we currently have, they are essentially duplicates. So 2 samples per different rock type. And so the 11th one will have a 12th one that will be of the same rock, hopefully. And so what we plan to do, or what Perseverance will do, is to deposit a suite of something like 11 or 12 samples in the first depot within Jezero Crater. And so it'll have on board still something like 30 or 31 tubes to carry with it as it goes along. And those, from that point on, though, the plan is not to collect duplicates. And so once that first initial depot is situated, beyond that, there is not a plan to collect duplicates. And so the 30 tubes that will be carried on board Perseverance will thereafter essentially consist of the sort of 10 duplicates that we have from within Jezero, and then the additional sort of 20 or so samples will be sort of new samples that will be collected beyond Jezero Crater. Does that make sense?
Yeah, it does. Can I ask a follow-up question? If that's the case, that you're going to be traveling around with 30 samples in Perseverance, what happens if there's some fault with Perseverance and you're having to rely on the helicopters to collect samples? Are they only going to be able to take the ones from Jezero Crater, or will Perseverance be able to drop the ones that it's carrying? What will you do in that eventuality?
Right. So this, Richard, I could jump in, Minnie, if you want. Exactly what you said, right? That the plan will be, there's two options there, right? One is that if Perseverance has a problem, we can position it and have it just put the remaining tubes that it has, whether or not it be 30 or however many it has at that point, it can drop all the remaining tubes on the ground in a second depot, and so that would be the way to, and then helicopters would go get it from that spot, picking them up one at a time, as I said, and taking them back to the lander. If under the worst case scenario, and we don't really think there are very many credible or almost any credible scenarios where Perseverance will flat out stop operating with the sample tubes still inside of it, then we could send the helicopters and the lander, the retrieval lander, to the Jezero depot and get the first 12 as many described. Does that make sense?
Thank you. It does. Thank you.
Okay, sure.
And we are out of time. Sorry to cut it off. We've gone over a little bit. As I said, I know there are some other people who were hoping to ask additional questions. Do feel free to reach out to me, Karen Fox, or the folks you've been in touch with as you've got information on how to join this media briefing. We will be airing this on YouTube, so you will be able to go back over it. And again, those media who received an email from us will also have information for how they can download a recording of this. So thank you so much for being here today. I appreciate it. And until next time, thank you. Goodbye.
Thank you for your participation. That concludes today's call. You may disconnect at this time.